Okay, welcome to lecture 3.9. Okay, all I've done, I've filled in the cases for NS and ND, used N equals ND divided by NS. So I can substitute, divide by NS, several cases, numerator and denominator. And then you get this. You get P sub dd, n squared theta, divided by this term. PDS equals this term. PSS equals this term. The likelihood function. And by the way, so before I was calling it a function of NS and ND, we're not going to estimate the two separately. We're only going to estimate the ratio. So now our likelihood is just a function of N and theta. Okay, so if you were to program this in R, there's only two terms to maximize. Or you could do it in a spreadsheet. It's a little bit harder than the one parameter case, but in fact, that's going to be your homework problem. You're going to estimate a two parameter case. And I'll talk about it in a later lecture. But once we do that, N and theta just equals these P terms raised to ADD, ASD, ASS. By the way, these A terms, those are data. Okay, all they saw, those are going to be numbers like um, Levitt and Porter break this down into various times of the week. So if it's say Friday night, midnight to 1 a.m., their data is going to be something like um, I can't remember exactly, but 1,500 cases where of the fatal crashes. I don't think it's that high. Let's say it was 1,500 were two drunk drivers. So the ADD in that case would be 1,500. Maybe it was 2,100 cases where exactly one driver was drunk. So ASD would be 2,100 in that case. And then say 942 cases where both drivers were sober. So ASS would be 942. Um, so the key thing, notice this. So if you wrote Levitt and Porter for their data, and let's say, I'm only interested in that one case for, Friday night, midnight to 1 a.m. Can you send me your data? They don't need to do it in a spreadsheet. All they need to do is send you three numbers. Just write you an email. Say ADD equal whatever I said, 2,100. ASD equals 1,500. What did I say? I can't remember the numbers I just said a minute ago. All they'd have to do is just send you those three numbers. That's their data. So it's incredible. Then from that, you have the data. You can, and we're going to do this. You could program a spreadsheet or R, a little routine in R, something to maximize, to write out this likelihood as a function of those data. Okay, and you're going to fill in the P's. Okay, but that function will be, that likelihood will be a function of N and theta. Try to maximize your likelihood, get the values of N and theta that maximize that. Um, let's see, and what do you get? Okay, so for this class, um, this is not a class about optimal traffic policy or optimal alcohol policy. So I really haven't said a thing. I mean, in most classes you would talk about, here's the substance, everything. Here was the methods. I want you to learn the methods that they used, and we won't talk about or very little. But just in case you wanted to know, I did tell you that their estimate of theta hat was about 8. I can't even remember if they constrained that to be the same across the various times and days of the week. I think they didn't. So, but I think that was that number I'm getting was something like Friday night. And by the way, I said we're not going to focus on it. I don't remember exactly. I'm just going from memory. And you know what else? I try to think of those things when I'm driving sometimes. Like, what's the probability that guy next to me is drunk? What did Levitt Porter say? And I often can't remember because I've taught this paper 3 or 4 times now, and I still can't remember exactly. But according to my notes, theta d then equals theta d divided by theta s, the hats versions. Um, and then they also get, call it in hat. So this is around, in my notes, I put around midnight. I think it was around midnight at Friday night. They get in, okay, so remember that equals n d divided by ns. Remember, this was basically what I motivated this paper. I said, you do these checkpoints, you never know, how representative they are, if the cops are at the representative street, or if word can get around to the drunk drivers. So estimating the percent of drivers on the road who are drunk is pretty tough. So that didn't quite that. They've given the ratio of that, and that equals 1/4. And by the way, so if you just write out, if you wrote out nd divided by ns divided by 1 plus nd divided by ns, that's just equal 1/4 divided by 1 plus 1/4. That equals 1/4 over 5/4 equals 1/5. So now multiply numerator denominator by ns, and you get that equals nd divided by ns plus nd. And so that's got to equal about 20%. So that's the proportion of total drunk drivers as a proportion of the total drivers. So that's going to be about 20%. That's what they get. Okay, so I spent about 5 minutes on the substance of the paper. One final thing I want you to notice. We're in an economics class. I'm kind of a political scientist. This really isn't economics at all. We didn't use any economics tools, nor any the political science tools, nor public choice tools. All we did is just use a few statistics tools. So, for what it's worth, Levitt and Porter, they really weren't doing economics. But regardless, it was a big contribution, and I think that was part of the reason. You may recall, and if you saw the email that Levitt sent me, the Journal of Political Economy at first rejected this paper, and I think partly the author said it's not economics. You get that sometimes. Levitt and Porter, somehow they learned who the referee was. I think the referee identified himself to them, or maybe he's the editor, I'm not sure. And they said, oh, you know what? Here's how we can take care of your reservations. And then that person said, I changed my mind. We should publish this. And it's a really innovative technique. And both of them, I think, deserve lots of plaudits for this. And despite we're in economics class, I'm going to teach this paper, even though you could say it's not really economics. Okay, so that's the substance of their paper. You know what? I'm going to do 2 more mini lectures. I think it'll be 2. One, I'm going to give you some hints for your homework problem, and then I'm going to give you a little taste of what's coming up in the paper we'll do for session 4, which is the Daniel McFadden paper. But okay, next will be hints for the homework. Okay, so see you in that session.